Hello dear students, today we are going to learn about inside the atom. In this we have to study about the different research about this atom and internal structure of the atom. We have seen that matter is made up of molecules. Molecules are formed from atoms. Effectively, an atom is the smallest unit of matter. An atom is the smallest particle of an element which retain its chemical identity in all the physical and chemical changes. Scientists, on the basis of experiments, explain the nature of atom as well as the internal structure of atom. It started with Dalton's atomic theory. What is Dalton atomic theory? British scientist John Dalton put forth in 1803 his celebrated atomic theory. According to this theory, matter is made up of atoms and atoms are indivisible and indestructible. All atoms of an element are alike, while different elements have different atoms with different mass. A bundi laddu is found to have an internal structure. It is formed by sticking smaller particles, the bundis, to each other. However, the solid ball, broadly speaking, does not have any internal structure. The atom, as described by Dalton, turns out to be a hard, solid sphere with no internal structure. According to Dalton's atomic theory, the mass is distributed uniformly in an atom. The scientist J.J. Thomson demonstrated experimentally that the negatively charged particles inside an atom have mass 100, 1080 800 times, means 1800 times less than a hydrogen atom. Later, these particles were named as electrons. Common substances are usually electrically neutral. Obviously, the molecules of substances and the atom which combine chemically to form molecules are electrically neutral. Thompson Plum pudding model of atom. The plum pudding model of atom put forth by Thomson in the year 1904 is the first model of atomic structure. According to this model, the positive charge is distributed throughout the atom and the negatively charged electrons are embedded in it. The distributed positive charge is balanced by the negative charge on the electrons. Therefore, the atom becomes electrically neutral. This is the Thomson Plum pudding model of atom. Plum pudding or plum cake is Swedish prepared during Christmas. In old times, this dish was made in Western countries by adding pieces of dried fruit called plum. These days, raisins or dates are used. Then we see about Rutherford's nuclear model of atom. Rutherford studied the inside of atom by his celebrated scattering experiment and put forth the nuclear model of atom in the year 1911. This is the Rutherford's scattering experiment. Rutherford took a very thin gold foil and bombarded it with positively charged alpha particles emitted by a radioactive element as shown in this figure. He observed that a path of alpha particles by means of a fluorescent screen around the gold foil. It was expected that the alpha particles would get reflected from the gold foil if the positively charged mass were evenly distributed inside the atoms. Unexpectedly, most of alpha particles went straight through the foil. A small number of alpha particles get deflected from the original path through a small angle. A still smaller number of alpha particles get deflected through a larger angle, and surprisingly, one alpha particle out of 20,000 bounce back in the direction opposite to the this foil. A large number of alpha particles that went straight through the foil indicates that there was no obstacle in their path. It means that there must be mainly an empty space inside the atoms in the solid gold foil. The small number of alpha particles that get deflected through a small or big angle must have faced an obstacle in their path. It means that the positively charged and heavy part causing obstruction would be in the center of the atom. This is the Rutherford's nuclear atomic model. With the help of this experiment, we can say there is a positively charged nucleus at center of an atom. Second, almost the entire mass of the atom is concentrated in the nucleus. And third, negatively charged particles called electrons revolve around the nucleus. Fourth, the nucleus, the total negative charge on all the electron is equal to the positively charge on the nucleus. As the opposite charges are balanced, the atom is electrically neutral. And fifth, there is an empty space between the revolving electron and the atomic nucleus. Then we will see about Bohr's stable orbit atomic model. In the year 1913, Danish scientist Niels Bohr explained the stability of atom by putting forth stable orbit atomic model. The important postulates of Bohr's atomic model are as follows. That is, one is the electrons revolving around the atomic nucleus lie in the concentric circular orbits at certain distance from the nucleus. Second, the energy of an electron is constant while it is in a particular orbit. And third, When an electron jumps from an inner orbit to an outer orbit, it absorbs energy equal to the difference of the energy, difference of its energy level. And when it jumps from an outer orbit to an inner orbit, it emits energy equal to the difference of its energy level. Then we will see about atomic structure with the help of all these research. An atom is formed from the nucleus and the extranuclear part. These contain three types of subatomic particles. That is, in nucleus, proton and neutrons are there, and in extranuclear part, electrons are there. Nucleus. The atomic nucleus is positively charged. Almost entire mass of the atom is concentrated in the nucleus. The nucleus contains two types of subatomic particles together called nucleons. Protons and neutrons are the two types of nucleons. Out of them, what is proton? Proton is a positively charged subatomic particle in the atomic nucleus. The positive charge on the nucleus is due to the proton in it. A proton is represented by the symbol P. Each proton carries a positive charge, that is 1 electron equal to 1.6 into 10 raised to minus 19 coulomb. Number of protons in the nucleus of an atom is the atomic number of the element and is denoted by symbol Z. Mass of one proton is approximately 1 U. U means Dalton. Then neutron. What is neutron? Neutron is an electrically neutral subatomic particle and is denoted by the symbol small n. The number of neutrons in the nucleus is denoted by the symbol capital N. Atomic nuclei of all the elements except hydrogen with atomic mass 1 Dalton contains neutrons. The mass of neutron is approximately 1 Dalton, which is almost equal to that of the proton. Then extranuclear part. The extranuclear part in the atomic structure includes electrons revolving around a nucleus and the empty space in between the nucleus and the electron. Then electron. Electron is a negatively charged subatomic particle and is denoted by the symbol E. Each electron carries 1 unit of negative charge. Mass of an electron is 1800 times less than that of hydrogen atom. Therefore, the mass of an electron can be treated as negligible. Electron in the extranuclear part revolves in the discrete orbit around the nucleus. The orbits being three-dimensional in nature, a term shell is used instead of term orbit. The energy of an electron is determined by the shell in which it is present. The number of electrons in the extranuclear part is equal to the number of protons in the nucleus. Therefore, electrical charges are balanced and the atom is electrically neutral. The mass of an electron being negligible, Therefore, the mass of an atom is mainly due to the protons and neutrons in its nucleus. The total number of protons and neutrons in the atom is atomic mass number of that element. The mass number is denoted by the symbol capital A. The convention to denote atomic symbol, atomic number and mass number are together is shown is like this. Here you have to write the symbol and here atomic number and atomic mass number. This is the atomic number, this is atomic mass number. For example, the conventional symbol atomic number of carbon is 6 and atomic mass number is 12. So you have to write like this. Here you have to write symbol of that element. Means that the atomic number, that is the proton number of carbon is 6 and the mass number of carbon is 12. From this, it is also learned that the nucleus of carbon contains 12 atomic mass and 6 atomic number, that is 6 neutrons. Dear students, we have to learn about next concept of this chapter in my next video. Till then, we have to read the lesson which is in textbook and you have to solve the exercise. Please see the next video for complete this chapter. Thank you.